bullet with a box question. This is a very classic question. One of my favorites to even talk about because this looks like a simple question. Why not just get MGH and be done with it with the kinetic energy equation? Done. It's done. No, it's not. The first thing I ask is total energy, which is quite easy. You just do this and you should get E. And again, it's variable form. But when you're trying to figure out H, you have to realize there's an energy loss over here. This energy loss does not show in total E, so it's like a trick question over here. The total energy into the system is actually just this. So this MV is the whole entire energy that came in, and when it hit here, the energy is lost by some wind or other factors. But sound probably, to be honest with you. But momentum needs to be conserved if it's perfectly inelastic either way, inelastic collision. So you can use this fact to figure out the moment inertia and the initial and moment initial on the final must equal each other, which gives you this format over here, which looks ridiculous. This is V over R, V divided by R is this L, by the way. I should have wrote that, but I didn't do it. I was too lazy. Now, this is point masses, so you can kind of see what the moment of inertia would be. It's just mass multiplied by length square, right? It's kind of obvious at that point. Anyways, with that thing, you can get omega and plug it back here with the variables and get this format over here. Now, that omega, if you have that omega over here, you can go back to energy again. And now you have something that is relatable to height. Now you could have used MGH and reverse engineer velocity from the omega, but the easier way to say it is that there's an access point, and there's no translational energy here. It's not moving anywhere because the access point, if it's not moving, it means that there's no translational energy if you make it omega and make it rotational. And with that rotational, you can do this format over here and just solve it. You can just solve for H. It's that simple. And you get this at the end, which is how you can get H or theoretical H, because there's definitely going to be more lost energy with the system friction and all that. But it's a good approximation, better than if you were to just do velocity, MGH, and all that shenanigans. So it's a beautiful question because it uses momentum and then energy. I love this question. It's one of the ones that's yeah, I understand angular energy, angular momentum. Over here, I'm thinking of using a spring over here to make a weird question, but didn't have time for it, so I'll do that later, but that's the plan.